By this year, the automotive industry stands on the precipice of a tipping point that could completely change the game. The Chinese company BYD is launching a battery pack into the market capable of propelling a car for over 1.2 million kilometers. That's about 750,000 miles. And it can charge from near empty to a high capacity in the time it takes you to buy a cup of coffee. Most importantly, we aren't talking about an experimental prototype hidden in a Silicon Valley lab or a futuristic project yet to see the light of day. We are talking about the Blade Battery 2.0, a real commercially available power system. It might just be the technology that redraws the geopolitical map of the transportation sector as we know it today. To understand the magnitude of this breakthrough, we first need to understand the logistical hurdles that have kept internal combustion engines in a position of dominance for over a century. For decades, electric vehicles collided with two main obstacles they couldn't easily overcome: refueling speed and battery lifespan. If you plug a mid-sized EV into a traditional 150 kilowatt fast charger, you have to wait around 68 minutes. Meanwhile, filling up a gas tank takes no more than 5 minutes. This time difference didn't just cause what we call range anxiety, it turned into a genuine logistical crisis that stifled the widespread adoption of EVs. The problem didn't stop there. It extended to the chemical degradation of battery cells. For years, consumers lived in fear of the cost of replacing a battery, which could reach tens of thousands of dollars, a bill hefty enough to turn any used EV into scrap metal the moment its warranty expired. However, BYD announced they've broken this equation. They introduced a battery that can go from 10% to 70% in just 5 minutes, offers a range exceeding 1,000 kilometers, over 620 miles on a single charge, and features a degradation curve so low that it ensures the chemical cells might outlast the very metal chassis carrying them. But how did a Chinese company that started in a tiny workshop manage to solve a physical and chemical challenge that many believed was almost impossible? And how did it achieve what giants like Toyota, after years of betting that hydrogen, not batteries, was the future, couldn't? The surprising part is that the answer doesn't begin with massive research budgets or giant laboratories. It begins with a brilliant chemical insight, a simple discovery hidden inside the atomic structure of traditional batteries, a discovery that changed everything. And step by step, we're about to uncover exactly what that secret was. The true story behind this breakthrough dates back to 1995 in China's Anhui province. There, a chemist named Wang Chuanfu grew up under harsh conditions but possessed an exceptional understanding of kinetic chemistry. Wang borrowed the equivalent of 250,000 yuan to set up a small workshop in Shenzhen, naming it BYD. He started by dismantling Japanese mobile phone batteries, studying their reactions at the atomic level, and then reverse engineering them to be denser and cheaper. By 2005, his batteries were powering more than half of the world's mobile phones. In 2002, Wang took a step that everyone considered financial suicide. He acquired a struggling automaker and announced his intention to build electric cars. While traditional car companies were focused on improving the mechanics of combustion engines and tweaking direct injection systems, Wang realized that the future of cars wouldn't rely on gears and pistons, but on electrochemical reactions. By 2022, that obsession had paid off. BYD had overtaken Tesla to become the world's largest seller of electric vehicles. And it didn't happen because of self-driving software. It happened because BYD mastered the one component that matters most: the battery. In automotive engineering, whoever controls the powertrain controls the market. And in the electric era, the battery is the engine. But one terrifying problem still haunted the entire industry: thermal runaway. How do you build a battery that stores enormous amounts of energy, charges in just 5 minutes, and still remains safe in a serious crash? BYD's answer wasn't just a new battery chemistry. It was a completely different way of designing the battery itself, an architecture inspired by the structural principles of the car. An innovation called the Blade Battery. and it may completely change the way you think about electric vehicles. While Tesla and most of the industry were pumping billions into developing nickel-manganese-cobalt batteries in pursuit of higher energy density, BYD took the opposite path. They focused on an older, highly stable chemistry known as lithium iron phosphate. Historically, this chemistry was shunned in cars because it was heavy and didn't store enough energy. But its killer feature lay in its molecular bonds. The phosphate and iron form an incredibly strong crystalline structure, an olivine structure that does not release oxygen when temperatures spike. This means it is nearly impossible to ignite and boasts a lifespan bordering on immortality compared to rapidly degrading cobalt batteries. The question was, how do we make this safe chemistry deliver a 1,000-kilometer range? This is where the brilliance of merging chemistry with automotive engineering shined. They drew inspiration from the unibody chassis concept and applied it to batteries. Traditionally, batteries are made of cylindrical cells placed inside modules, which are then packed into a large housing, wasting about 50% of the space. BYD eliminated this through cell-to-pack technology. They stretched the cell to become long and thin like a blade and stacked these blades tightly together. Amazingly, the cells themselves act as structural support beams for the car's foundation, much like steel columns in buildings. This design increased space utilization by over 50%, allowing a massive amount of LFP material to be crammed into a small footprint. The result is a battery that doesn't catch fire even if pierced by a steel nail and can withstand thousands of charge cycles without degradation, justifying that 1.2 million kilometer warranty. On top of that, it's designed to charge efficiently in temperatures as low as negative 22 degrees Fahrenheit, going from 20% to 97% in just 12 minutes. But with this legendary range and insane charging speed, the world collides with an infrastructure nightmare. To charge a car in 5 minutes, you need stations that draw power equivalent to what an entire residential neighborhood consumes in a single moment. This would mean the collapse of power grids in major cities and the burning out of transformers. So, how did the company plan to avoid this catastrophic meltdown? The solution wasn't in beefing up the grid, but in inventing a parallel network that no one sees. The game-changing number here is 1,000 kilowatts. To enable this speed, BYD unveiled its Super E platform, which allows a massive current to flow at 1,000 volts, adding 400 kilometers, about 250 miles, of range in 5 minutes. For comparison, Tesla superchargers mostly operate at 400 volts and are only gradually moving to 800 volts. But hooking a 1 megawatt charger directly into the local power grid is electrical suicide. The brilliant workaround lies in energy storage buffers. Instead of pulling massive current from the city's grid the second a car arrives, BYD is building giant underground storage batteries next to the charging stations, often using recycled older battery cells. These stations slowly and quietly absorb electricity from the grid throughout the day to store it. Then, when your car rolls up, the energy is discharged like a torrential flood from the station's battery into your car's battery, completely shielding the city's grid from any stress. This takes us to another dimension, V2G, or vehicle-to-grid technology. With a battery that lives for 1.2 million kilometers, while the car's chassis lifespan barely exceeds 300,000 kilometers, a car might be scrapped while its battery still runs perfectly. These batteries will transition into home power stations, supporting the electrical grid during peak hours. Your car will no longer just be a mode of transportation. It will become an energy storage unit that generates income by selling electricity back to the national grid. The company is currently rolling out nearly 6,000 of these V2G-enabled charging stations across 312 Chinese cities by mid-2026, building a fully integrated energy ecosystem. BYD is not alone in this arena. This staggering progress has opened the door to a genuine global arms race. The fierce Chinese competitor CATL recently launched the Shenxing battery, also based on LFP chemistry. capable of adding 250 miles in just 10 minutes. The race is no longer confined to America and Europe. It has become a vicious battle for technological supremacy in Asia. On the other side, industry giants like Toyota are watching the scene with anxiety. For a long time, Toyota bet heavily on green hydrogen fuel cells, like with the Mirai model, believing that the weight and charging time of batteries would never be solved. But the efficiency breakthroughs of LFP batteries have dealt a severe blow to the viability of hydrogen in the passenger car sector, especially considering the massive energy losses during hydrogen conversion and storage compared to the direct transfer of electricity to batteries. But the next great battle is now taking shape on the horizon of solid-state batteries. Companies like Mercedes-Benz have driven a modified EQS over 1,200 kilometers using fully solid cells free of flammable liquids in collaboration with American startups like QuantumScape. And BYD is not lagging behind. They have announced that their solid-state battery will enter limited production in 2027 and mass production by 2030, paving the way for a revolution in heavy trucking and electric aviation, sectors previously deemed impossible due to the weight of current batteries. What all of this means is that the last argument for sticking with gasoline cars has fallen. While the world was arguing about infrastructure readiness, the numbers were being completely rewritten in silence. The era of hesitation is over, and we have officially entered the age of electric immortality. You are now standing on the front line of this revolution, holding the complete picture before it hits the mainstream headlines. If this deep engineering breakdown gave you a new perspective, hit that like button and subscribe to World Uncovered Tech. Let me know what you think in the comments. A battery that outlives the car itself? Is this the breakthrough that will shut down combustion engine factories forever? Or will the ghost of hydrogen and solid-state tech flip the table once again? Stick around and watch the next video because the alternative energy war just entered a bone-crushing phase.